Okay, so today we're going on to section 1.2 notes to determine whether a table, graph, or equation are linear or not. That's what we're going to be focusing on. So in 1A today, they said to make a table showing the distance walked by each student for the first 10 seconds. How does the walking rate appear as a pattern in the table? Well, over here, right to the right of that question, they told us that Elena walks, her walking rate is 1 meter per second. Gilberto's is 2 minutes per second. Leanne's is 2.5 meters per second. So if we were to look at this table off to the right, at 0 seconds, we know they're all going to be at 0 meters. Okay, so since we know those are all going to be 0 because there's no seconds, so they didn't even start yet, we can go on to Elena to see that at 1 second, what's the distance that Elena's walking? Well, we know that her walking rate is 1 meter per second. So in 1 second, she's going to be walking 1 meter. And then so on. In 2 seconds, she's going to be walking 2 meters. And so on from there. 3, 4, 5, 6, 7, 8, 9, 10. 10 seconds, she's going to walk 10 meters because in 1 meter, she'll walk 1 meter per second. So same thing with Gilberto. He's going to walk 2 meters per second. At 1 second, he's walking 2 meters per second. At 2, these are multiples of 2 now, so we're going to go to 4. At 3 seconds, he's going to have 6, 8, 10, 12, 14, 16, 18, and 20. So at 10 seconds, Gilberto's going to be walking 20 meters. And then so on with Leanne. We know that Leanne walks 2.5 meters per second. Well, they told us in that walking rate that in 1 second, she's 2.5 meters. Well, we know that that's a constant rate of 2.5. So if we go on from there, it'll be 5 meters in 2 seconds, 7.5, 10, 12.5, 15, 17.5, 20, 22.5, and 25. So at 10 seconds, Leanne's going to be walking 25 meters. So over here underneath 1A, it says, how does the walking rate appear as a pattern in the table? Based on what we just found, what is the walking rate? With your shoulder partners for a minute, talk to them as to what you think the walking rate will be based on the pattern that we just created in the table. Okay, so for this walking rate, we saw that the walking rate is the amount, the distance is changing as time increases. So our walking rate is at constant. The greater rate, the more quickly the distance increases. So as we go on to 2, it says graph the distance and times for the 3 students on the coordinates. Well, I would use a black pen, a blue pen, and maybe a pencil, or if you have color pencils or markers. If you don't have anything available, maybe borrow from someone. If not, we can just label it as we go. So I'm going to use red for Elena, and I'm going to look at my table that I just created above, and I'm going to plot my points so that I can create a line. Elena is at 0, 0, and then we know she goes up by 1. So at 1, she's at 1. At 2, she's at 2. 3, she's at 3. 4, she's at 4, and so on from there. 5, 6, 7, 8, 9, 10. And her max is 10. We don't even go further than that. So if I were to connect this line, oops, let's move this. Let's see how accurate. There it goes. Okay, that looks pretty good. And if you don't have multiple colors, you can just leave this as A over here so that you know that you labeled A as Elena. So my red line is Elena. My green line is going to be Gilberto. So he's at 0, 0. That's where they all start. And we said that 2 meters per second is his constant. So at 1 second, Gilberto is at 2. Our seconds are on the bottom. They set up this graph for us. So at 1, 2, and then at 2, 4, 3, 6, 8, 10, 12, 14, 16, 18, and we can go off the graph a little bit. So there's all the points for Gilberto's line. And if I were to connect these, make it just like that. I can connect my arrow because that's going to keep increasing. We just don't have enough room on our graph to keep going. And I'm going to put a G. So if you have just a pencil, you can label it just like that, just so you know which line is which. If we go on to our last one and do Leanne, again, she's going to start at 0, 0 because that's where they all start. And she goes up by 2.5 meters per second. So at 1 second, she's at 2.5. At 2 seconds, she's at 5. 3 seconds, she's at right here. 4. 10. And 12.5. 6 is at 15. 7 is at 17.5. And I can try another one. 8 can be at 20 up here. So that's my line that I'm creating. And if I were to connect these points, just like so, I got my arrow because it's increasing, and I'll put L for Leanne. Now I know which line is for which person. So now that we created our graph, talk with your face partners about how does the walking rate affect the graph. Based on what we see here, what's happening in this graph. I'll give you about a minute. Okay, let's come back together now. And how does the walking rate affect the graph? What do you think? Yeah. Okay, that sounds great. The walking rate affects the graph by the greater the rate, the steeper the graph. As you look up here, look how steep it's getting over here. The greater this rate, the steeper it's going to get. As we go on to 3, write an equation that gives you the relationship between the time, t, and the distance, d, walked for each student. How is the walking rate represented in this equation? Okay, so I know Elena, there's hers. We did Gilberto in green, and Leanne in red. So we want to come up with an equation. D equals something. D equals something, and we want our time. Well, we know 1 second in our time is 1 meter in Elena's time. So D is really just going to equal T. So what do you think for Gilberto? If he is D equals what? Based on the constant and based on our table that we found, what kind of equation could we create to do this? Yeah? Okay, so for Gilberto, his constant's 2, so you want to do 2 times T. 2 times whatever time it is to get what the distance is. So if we were to go on to our last one, Leanne, D equals, we have one last one, just like Gilberto. Okay, 2.5 T, because that's their constant. That's what they're going to go up by. So the walking rate is the number being multiplied by the time. Our walking rate times our T, our time. And 4, how can you predict that the graph will be a straight line from the patterns in the table and in the equation? Well, don't even look at the graph. We just created our graph. Based on that table that we created at the top, and based on those equations that we just wrote, How can we determine whether this is a straight line? Yeah? Okay. So in the table, there is a constant rate of change. Perfect. What about the graph? Or in the equation, I mean? Each equation is written in the form y equals mx. We don't have a b. We don't even include it. We just have our mx, which is our slope, which is our constant rate, which is our walking rate. So if we go on to the next page, it says, are any of these proportional relationships? If so, what is the constant of those proportionality? With your shoulder partners again for a minute, determine whether they are proportional relationships, and if they are, tell me what the constant is for each of those people. And we'll come back in a minute. Okay, let's come back together. Okay, are any of these proportional relationships? Yeah? Okay, you say they are. Hands on your head if you think all three of these are proportional relationships. Okay, a lot of you think that. I agree. All three are proportion relationships. Now let's specify what each person's constant is. A for Elena, her constant is 1. Every second, she goes up, or she goes 1 meter. Gilberto G, he is 2. And for Leanne, every second she goes 2.5 meters. So those are their constants, their constant rate, their walking rate. If we go on to part B, we have that same table that they showed us in the front. And B, it says for each student, 1, if time t increases by 1 second, by how much does the distance d change? How is this change represented in a table and in a graph? Well, in B1, all they want to do is, if the time is 1 second, how far are each of them going to be? In 1 second, Elena's distance is going to increase by 1 meter. So what about Gilberto? In 1 second, where is his time going to go? Yeah, it's going to increase by 2. And lastly, Leanne. Perfect. She's going to increase by 2.5. So if we use those points, have it. So now that we did their increasings for Elena, Gilberto, and Leanne, let's look at the tables and the graphs. In this table that we created on the front page is their increase by 1 second. So in that, we can see that this increase will show between distant values. And again, with the graph, the lines will get steeper, like we stated on the front page. Going on to B2, they said if t increases by 5 seconds, how much does d change? How is this change represented in a table? Well, before we were increasing by 1 second, now we're going to be increasing by 5. But we want to use those constants that we stated each one of them has. Our constant for Elena is 1. So if in 5 seconds, in 1 second, if she's going to go 1 meter, in 5 seconds, she's going to increase by 5 meters. And then Gilberto, since he increases by 2 in 1 second, what is he going to increase in 5 seconds? Going to increase by 10. And then lastly for Leanne, she's going to increase by what if there's 5 seconds? Increase, since in 1 second she's 2.5, in 5 seconds she will be 12.5. And then when we compare this to the table and graph, it's exactly like B1. Our table and graph is exactly the same. We're just looking at different points on it. So instead of rewriting it, I'm just going to put this asterisk here, which means it's the same as stated above in our tables and graphs. If you want to rewrite it under those columns, you can. But if you want to just put these marks, as long as you know what they mean, you can also put those. And lastly, let's get started on B3. It says, what is the walking rate per minute? Well, we've been working in seconds. In how many seconds is 1 minute? In 1 minute, there is 60 seconds. We're making some conversions like we were doing last week. So it says per minute, what is Elena's time? In 1 minute. Well, in 1 minute, Elena walks, in 1 second, Elena walks 1 meter. So we got to multiply that by 60 to figure out how far she's going to walk in 1 minute, which would be 60 for Elena. And then so on. We're going to do the same thing for Gilberto and Leanne. We got to figure it out in minutes, and since we already have it in seconds, we're just going to multiply that number by 60 to determine what it is in minutes. So Gilberto's constant is 2. So we do 2 times 60 to give us 120. And lastly, for Leanne, since her constant is 2.5, we'll multiply that by 60 to figure out the minutes to get 150. And then we will go on to do the hours, and we'll do part C in our summary tomorrow. So we will stop the video here, and we will continue tomorrow.